Here's the third method. Again, back to the first question on finding the time. Find the time between 2 and 3 when the hands of the clock coincide. This again uses a reference. I'm going to take 2 o'clock as my reference, and my required time will look like this, something like this, where the hour hand is here, minute hand is also here. This is where it starts to differ. I just call this portion as X minutes, right? And then I say uh, minute by hour is 12:1, isn't it? So from the reference time of 2 o'clock, the minute hand is moved from 12 to 2, which is 10 minutes, and then is moved further from uh, whatever this is, another X. 10 and X is the total movement of my minute hand, 10 plus X, while the corresponding movement for my hour hand is simply X. And so these distances have to be in the ratio 12:1. We can use that to solve this. That gives me 12x is equal to 10 plus x, 11x is equal to 10, x is equal to 10 by 11. Notice that this is the portion after the 2 marking on the clock. So the time is 10 by 11. The minute hand reading is 10 by 11 after 10 minutes. So the time is going to be 2 hours 10 and 10 by 11 minutes. Now you might be asking, why do I need this method when you have all these other methods? I have the answer to that. Behold, this is what cat will throw at you, and which will stump you when you go in with just formulae. You need the actual fundamentals to solve this kind of a question. And the question is, find the time between 2 and 3 when the angle between the hands is bisected by a vertical line. What does this look like? This is what it looks like. This would be your 3 o'clock, and a little bit before 3 you have the situation where the hour hand is here and the minute hand is here, and you have bisection. So what I'm going to do to solve this kind of a question is the method that we just described, where I'm going to take this as x and this should also be x. So basically your angle on the left side of the vertical is 10 plus x, angle on the right side is also 10 plus x, and you have bisection. So again, what you'll do is you'll take your reference of 3 o'clock and then you say that the minute hand is moved back by 10 plus x. From my reference of 3 o'clock, I'm moving the clock backwards, and the minute hand is moved 10 plus x, while the hour hand is moved what we can describe as 5 minus x. That's the best way to go about this, right? That is x, this will be 5 minus x. And 10 plus x and 5 minus x are in the ratio 12:1, which gives you 10 plus x is equal to 60 minus 12x, which is going to give you 13x is equal to 50, and x is equal to 3 and 11 by 13. So that is the time you have to move back from 250, because this is what you need. Subtracting 3 and 11 by 13 from 250 will give you 246 2 by 13. This is your answer. The time would be 46 and 2 by 13 minutes after 2 o'clock. And you can't do this with anything else. Notice that for the first time we're getting a remainder of 13 while we usually get 11. And this is typically what happens when you talk about bisection. This I've noticed on the questions on bisection that this is a denote of 13 as opposed to 11, and you cannot get this with the first two approaches. This is the most fundamental way of solving this question, where what is the fundamental? It is the distance moved are in the ratio 12 by 11, and your whatever unknown portion you have, the fractional portion between the multiples of 5 minutes, you're taking as a variable and you're solving as a linear equation. This is the most fundamental approach. This can solve any question on clocks. Even questions where they'll modify the clock to say 1 hour is 80 minutes and there are 10 hours in a day and all that nonsense. Anything can be solved by this question, this approach.